Welcome back, fellow developers. In the last chapter, we ran our first DAG on MWAA, and also we checked out how to look at the logs in CloudWatch. In this chapter, we are going to cover two exciting topics: setting up the CloudWatch dashboard for MWAA metrics using Pulumi, and also creating a DAG that transfers data from Aurora Postgres to Redshift Serverless using S3 as an intermediary. Let's look at the dashboard that's been created by our Pulumi code. I have only added 5 metrics. Just as an example, I'll be adding the link in the description below on the metrics that are available in CloudWatch for MWAA. One of the important metrics to keep an eye out on is the scheduler heartbeat. If the scheduler is not running, none of the tasks are actually going to run. Hence, you need to make sure that the scheduler is running. Along with the scheduler, you also have to keep an eye out on the celery worker and the DAG triggerer. I have only added celery worker heartbeat to this dashboard. So if the worker itself is not running, then even if the scheduler tries to schedule anything, it's actually not going to be picked up, and none of the tasks are actually going to run. This is especially true for MWAA, as MWAA uses the celery executor for running its code. From a DAG perspective, two important metrics are DAG success time and DAG failure time. Using DAG success time, you can keep an eye out on the trends on how long does your DAG take to run. Looking at the trends, you can see if your DAG needs optimization. If you notice a weird drop on the graph for DAG success time, kudos on quickly catching the weirdness. We'll talk more about why that happens when we take a look at what we are trying to achieve for the ETL flow we will be writing. Let's now look at the code for generating this dashboard. Pulumi does not have a great type-safe interface for writing all these metrics. Instead, we need to pass in a list of dictionaries to the dashboard objects. I'll be linking the AWS page that has the structure of these objects in the description below. Now, this a list of dictionaries are then passed on to the dashboard object, as you can see in the code that's also linked in the description below. Let's look at the ETL flow that we are going to be writing to illustrate the example. It's very basic. All it's doing is it's going to fetch data from RDS, pull the data onto the MWAA worker, then put the intermediary data on the S3 bucket. In the end, it's going to store the data in Redshift. The components we are going to use are Aurora Postgres Serverless instance, Redshift Serverless, and a S3 bucket. I'm using serverless wherever I can so that I can save on money, and I get charged only when I use those instances. To keep this DAG simple, I'm going to be using Airflow's UI to store the connection details for Aurora Postgres and Redshift. If you are running the example using the Pulumi code I provided, make sure you create those connections through the Airflow UI. A good practice, though, is storing these connection details in AWS Secrets Manager or Systems Manager so that all these secrets are not maintained manually. Please let me know in the comments below if anyone's interested in me creating that video. If there is interest, I'll make one using Airflow Secrets backend to use Secrets Manager. Taking a look at the Airflow code that we have written up, the first 2 steps are basically setup steps. First is going to just set up the table if it does not exist in the Postgres database, while the second one is going to generate random data and add it to the Postgres table. Looking at the first method, you can see that even if we run it multiple times, the end result is just going to be creating a table if it doesn't exist. The second method, however, does have like a side effect to it. It doesn't care if the table already has data or not. It's just going to insert 10 more rows. The third step is extracting the data from the RDS instance and storing a CSV onto this S3 bucket. The fourth step is similar to the first step that we have done for Postgres, where now it's going to create a table if it does not exist in Redshift warehouse. The last step is actually copying over the data from S3 to Redshift. This is where Airflow shines, in my opinion. There are so many pre-built connectors or operators which we can just use out of the box. The important one for us in this example are the method, which is absurd in this case. This will tell the operator to deduplicate the records based on ID on the Redshift side while copying it over. You can use other options. Method also supports other options like append only. So if you want to treat the Redshift table as a log, where you would just keep on adding duplicate records, then append only is what you would end up using. The other important parameters that we passed onto this operator are the copy options, where we tell Redshift that it's the data that it is expecting is actually a comma delimited CSV. Thank you for joining me in our first fake but realistic simple data pipeline. These skills and techniques will help you deal with the quirks that MWAA throws at you. In the next video, we are going to dive deeper into scaling and monitoring Airflow, so stay tuned for that one. If you like this video, please like and subscribe and hit the bell icon to get notifications for all the updates. I'll see you again in the next week. Enjoy your week and keep learning.